Hello everyone. In this video, I want to talk about some of the basics about mathematical proof, some of the foundational ideas and methods on how we prove something in math and in geometry specifically. So to start off with, I have the definition of a proof. It's a logical argument that uses deductive reasoning to show that a statement is true. So we think of a conjecture, a hypothesis, something that we want to justify. We want to show that it's true. A proof is a logical sequence of statements that shows that it is true beyond a doubt. So this sort of idea exists in other places as well. So for example, if you've ever had an experience writing code, a lot of times the code is written as if this is true, then this next piece will be true. And if that's true, then this next piece is true. And that's how we want to structure a proof in math as well. So I have some tips here as well for writing a proof. So I said start with the given information. Now a proof has three parts. Just like when you're writing a story, we have a beginning. These are the things that are given to us. These are the statements that we're assuming are true. This includes given information or given information from a diagram or definitions or other things that we already know are true. Then after that, we have a middle. So this is where we're stringing together these logical statements, right? We're creating a logical sequence to lead us to our conclusion, which is the last part, which is the statement that we're trying to prove. The next tip, statements of the same reason can be combined together into one step. So this will save us some writing time. The next one, draw a picture and mark it with the given information. So a lot of times we're going to be dealing with shapes. So if we draw a picture and we label it as we go through the proof, it's going to help keep us organized. As we go through, every statement has to have a reason. So I can't just state something without having some reasoning to back it up. The order of the statements in the proof is not always fixed, but it has to make logical sense. So a lot of times there is no one correct answer, no one correct way that we should go through a proof, but we do have to make sure that each step follows logically from the one before it. And then the last tip are justifications. This can include anything from definitions, postulates, properties, for example, transitive property or other properties we have for equality or congruence, or previously proven theorems. So once we prove a theorem is true, it's always going to be true, and then we can use it to prove other theorems. And this is how this geometry is built, right? It's this logic system. We start off with something basic, we use that to prove something else, and then we keep building upon that. So let's run through a simple geometric proof. So this is how my information is presented to me. I have a given, so this is a statement that we're assuming to be true, and then I have a statement that I want to prove. So in this case, my given information is the measure of angle 1 is equal to the measure of angle 3. Now I think a good idea would be to mark that in my diagram right away. So if these two angles are equal, I can indicate that with two little arcs in the corner. So now I can look at my picture and I know that those two angles are the same. And then the statement I want to prove is that the measure of angle DBA is equal to the measure of angle EBC. So why don't I just highlight those two angles so we get a better idea of what we're looking at. So the measure of angle DBA, I'll highlight that in blue. So from D to B to A like this, so that angle, we want to show that that one is equal to the measure of angle EBC. So from E to B to C. So the two angles that I want to show, I want to prove that these two angles are congruent, are equal, they do overlap a little bit. So let's start writing our proof. One way that we can write a proof is with a two-column proof. So we're going to organize our statements that we want to connect together in one column, and then our other column will put all the justifications for those statements. So we'll do our statements in one column and our justifications in another. So as I said, we want to start with our given information. So that statement that we're given up top, I'm going to rewrite that. So the measure of angle 1 is equal to the measure of angle 3. And my justification here, this is just a given. So we're assuming that this is true. From here, it may not be obvious where I want to go next, but I do know where I want to end up. So I have these two angles that I want to show are the same. So because I know I want to work with those angles, I need to get them into my proof somehow. So I'm going to write a couple statements that relates those two angles to the 1s, 2s, and 3s I have in here. So for example, the measure of angle DBA, if I take a look at what makes up that angle is the same as the measure of angle 2, so from here to here, plus the measure of angle 3. So if I put those two angles together, I get this angle DBA. So this is the same as the measure of angle 2 plus the measure of angle 3. Now my justification for this, I'm adding two angles together, giving me a bigger angle. This is a postulate we've already established. This is the angle addition postulate. So the way that I'm structuring this is I'm writing a statement, and then my justification is how do I know that statement's true? So how do I know I can add two angles together to get a bigger one? The angle addition postulate. And while we're at it, why don't we do the same thing for the angle EBC? So the measure of angle EBC, if I take a look at the diagram, I can see that that angle is made up of angle 1 and angle 2 put together. So the measure of angle EBC is the same as the measure of angle 1 plus the measure of angle 2. And my justification for this is actually the same. This is also the angle addition postulate. So again, the way that I'm thinking about this is how do I know I can write this statement? What tells me that this third statement is true? Well, it's the angle addition postulate. All right, so next, if I take a look at what I have, I know that eventually I want these two angles to be the same. Well, the things that they are equal to almost match up, but not quite. One of them is the measure of angle 2 and the measure of angle 3, and the other one is the measure of angle 1 and the measure of angle 2. They both have the measure of angle 2 in there, but it's the other piece that doesn't quite match up. However, our given was that the measure of angle 1 and the measure of angle 3 are the same. So that means we can substitute those for each other whenever we want. So what I'm going to write next then is the measure of angle EBC. So I'm going to take this statement right above. Now instead of the measure of angle 1, I'm going to substitute in the measure of angle 3. So I'm just going to replace that. So how do I know I can do that? Well, that's just the substitution property of equality. So now I know that EBC is the same as angle 2 plus angle 3. I also know that angle DBA is the same as the angle 2 plus the angle 3. So if both of those are equal to 2 plus 3, they have to be equal to each other. So I can finish up, and this is my conclusion. So what I want to prove is this last statement. So I am just going to copy that down. The measure of angle DBA is equal to the measure of angle EBC. And then how do I know I can do that? My justification here, what I have is DBA is equal to angle 2 plus angle 3, and EBC is equal to that same thing. And this is our transitive property. So the transitive property of equality says that if two things are equal to the same thing, then they're equal to each other. And that's it. So that's the statement we wanted to prove. That's the end of our proof. So to indicate that we are done, I'm going to put a little box here just to show that the proof is over. That indicates to the reader that there is no more justification coming after this. So that's just a simple example of a proof using some of the things that we've already established. some postulates, and some of our properties of equality. But remember, all this is, it's a logical argument. This is not the only way I could have tackled this. This is just what came to mind for me first. You may have thought of a different way, but it's a logical sequence of statements that shows that this is true beyond a doubt.